Our lesson goal for today is to be able to solve problems similar to this. In making Big Ziti, Alonzo used 5/12 of a cup of mozzarella cheese and 2/12 of a cup of Parmesan cheese. How much cheese did Alonzo use in all? In order to solve this problem, we're going to add the fractions 5/12 plus 2/15. In order to add fractions with unlike denominators, we are going to find the lowest common denominator. In this case, we're going to factor out of 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. We can see that 4 and 5 are relatively prime. That means no common factors other than 1. We're going to multiply the fraction that has a denominator of 12 by 5, top and bottom, and the fraction that has a denominator of 15, top and bottom, by 4. Our denominator is 60, and 5 times 5 is 25, plus 2 times 4, which is 8. 25 plus 8 is 33, and 33 over 60 we just have to reduce since they are not relatively prime yet. Therefore, we could factor out a 3. That leaves us with 11 over 20. Another way to reduce this is just to divide through by 3, top and bottom. This gives us our 11/20th. And this is, in fact, in simplest form. By the end of this lesson, I'll be able to add rational numbers, fractions, with unlike denominators. Our essential question is, how does knowing your math facts help in reducing fractions and finding the GCF and the LCM of two numbers? All right, in order to add and subtract fractions with unlike denominators, we have to find what we call the LCD. We take the 8 and the 6, and similar to how we were finding the LCM, the least common multiple, we're factoring out a 2, dividing 8 by 2, dividing 6 by 2, leaving us with two relatively prime numbers. That means that LCM would have been 24, but since these are denominators, we call it the LCD. And remember, 2 is the GCF. The least common denominator is just the LCM of our denominators. This means that the LCM of 24 is the smallest number that can be divided evenly by 8 and 6. 24 divided by 8 is 3. Notice we have a remainder of 0. 24 divided by 6 is 4. This means that 6 and 8 are not only divisors, but also factors of 24. 24 is a multiple of 6 and 8. When we take a look at this, when we write the multiples of 8 and the multiples of 6, we can see we have common multiples here at 24 as well as 48. But the least common multiple is 24. We can have an infinite number of common multiples, but there's only one least common multiple. All right, this is where I'm from, Elmont, New York, and something that people eat in New York a lot, pizza pies. So when we take a look, this is a regular pie, but then we also have the square type ones. The two most popular ones, I believe, are Sicilian and grandma pizza. So let's divide the Sicilian into 12 pieces and the grandma into 9 pieces. Would it be okay if I had the Sicilian and you had the grandma? We trade, I give you 5 of mine and you give me 5 of yours. Would that be an even trade? And you might think it's not, because you can see the Sicilian pieces would be a lot smaller than the grandma pieces. So what tells us the size of these pieces? And if you stated the denominator, you are correct. How do we actually compare fractions? One easy method is to cross multiply. We would go 9 times 5, which is 45, 12 times 5, which is 60. Notice that 60 is larger than 45. We would say 5/12 is less than 5/9. Let's keep this in mind. If we wanted to add 5/12 plus 5/9, here we have 5/12 shaded, and we also have 5/9 shaded. If I tried to add a larger piece into the smaller pie, we would see it doesn't fit because it's a little too big. If I tried to fit a smaller piece into a larger, it doesn't fit because it's too small. If I try to add 2, now it's too big. Hey, let's add 6 oranges to 5 apples. What would we have in our basket? Would it be 11 oranges or 11 oros? Nope, it would actually just be 6 oranges and 5 apples, because we're not making smoothies, even though that smoothie looks pretty good. So when we are adding, we are going to have the same size pieces. So I would divide the 12 piece each piece by 3 and the one with 9 pieces by 4. Let's start counting by threes. We have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. And let's start counting by 4. And this would give us 4, 8, 12, 16, 20, 24, 28, 32, and 36. So now we have, both of them have a total of 36 pieces. And that's our denominator. In the blue sections on the top, we can see we have 5 pieces divided by 3, or we're actually multiplying it by 3. That would give us 15 pieces. And the other one would be 5 times 4, and that would give us 20 pieces. Now we can add these up because we have what we call equivalent fractions. And if we wanted to check, we can see if we cross multiply, would we get the same answer? And if we cross multiply the other two fractions, we would see we would get the same answer. So now we can add. When we add, all we have to do is add the numerators because they have the same denominator. And 15 plus 20 is 35 over 36. These are relatively prime numbers, so we know we're in simplest form. But how did I know to multiply the first fraction by 3 top and bottom and the second fraction by 4? Well, this is what we were learning when we were trying to find the LCM. We're taking 12 and 9. We're factoring out that 3. 12 divided by 3 is 4. 9 divided by 3 is 3. Since these are relatively prime, we know we're going to find the lowest common denominator. So we're going to cross multiply. So that 3 is what I divided that pi into. When we're dividing it, we're going to increase the number of pieces, but not the size of the actual total pi. And then 4 times 9 shows us that that's why I divided that one by 4. This gives us a total of 36 pieces, and that's our LCM or LCD. And we should be familiar with this. When teachers tend to have pizza parties, they tend to make them into really small pieces. Standard would be 8 pieces, but they usually go for 16. They didn't increase the size of the pie. They just increased the number of pieces. In our last lesson, we learned we can add or subtract fractions with the same denominator. Fractions with the same denominator are called like fractions. So here we have the same denominators, those are like, and these are unlike. The 3 steps in adding or subtracting fractions would be rewrite the fraction with the same denominator by finding the LCM, and that's the LCM of the denominator. Step 2, add only the numerators. And step 3, reduce fractions to simplest form if necessary. When adding unlike fractions, we're going to have to do a little bit more work. Step number 1, we're going to rewrite fractions with the same denominator by finding the LCD. What number can we factor out of 12 and 16? And that would be 4. 12 divided by 4 is 3. 16 divided by 4 is 4. Now, the fraction that has a denominator 12, we're going to multiply the top and bottom by 4. The fraction that has a denominator 16, we're going to multiply the top and bottom by 3. This leaves us with 20 over 48 plus 15 over 48, where 48 is the LCD. So now when we add, since we have the same denominator, all we have to do is add the numerators together. 20 plus 15 is 35 over 48, and these in fact are relatively prime. So we're in simplest form. I'm going to start this problem on your guided notes. And you may want to write this down and pause it because we're going to do the 3 examples. And then the rest you have to do. Let's take a look at the first example. So step number 1, we're going to rewrite the fraction with the same denominator by finding the LCD. So what number can be factored out of 15 and 25? And that would be 5. 15 divided by 5 is 3. 25 divided by 5 is 5. The fraction with a denominator 15 will be multiplied top and bottom by 5. The fraction with a denominator 25 will be multiplied top and bottom by 3. This will leave us with 20 over 75 plus 21 over 75. Step number 2 states that we should add the numerators only. So this is going to leave us with 20 plus 21 over 75. And we'll have 41 over 75. And this is in fact relatively prime, so we know it's in simplest form. You may want to pause the video and try it yourself, or you may follow along. What number can we factor out of 12 and 9? Well, that would be 3. 12 divided by 3 is 4. 9 divided by 3 is 3. So the fraction that has a denominator of 12, we're going to multiply the top and bottom by 3. And the fraction that has a denominator of 9, we're going to multiply the top and bottom by 4. This gives us a LCD of 36, and we're going to have 15 plus 20 over 36. 15 plus 20 is 35 over 36, and 35 over 36 is relatively prime, so we are in simplest form. Let's take a look at another one. We need to find a common denominator. What number can go into 24 and 12 evenly? Well, that would be 12. 24 divided by 12 is 2. 12 divided by 12 is 1. 2 and 1 are indeed relatively prime. So therefore, the fraction that has a denominator of 24 will be multiplied by 1. And the fraction that has a denominator of 12 will be multiplied top and bottom by 2. This gives us a LCD of 24. And remember, there's lots of ways of getting this answer. If you didn't see 12, that's perfectly fine. You could have tried 4 and then 3, right? And that would give us our GCF of 12 and our LC. Always have to start from the bottom. Or we could have, instead of doing 4, we could have tried 3 and then 4. But remember, in order to find our LCM or LCD, we always have to start from the bottom. All right. And another way could have been, you could have did 2, and then 2 again, and then 3. 4 different ways. And counting, we could have then did 3, and then 2, and then 3, or 2, 3, 2. Lots of different ways to get your answer. From the bottom, now we're here. But remember, started from the bottom, now the whole team here. This one. We're going to have 5 plus 2 over 24, which is 7 over 24, and 7 over 24 is in simplest form. On this particular one, we're going to start off the same exact way. We know that 3 can be factored out of 12 and 9, 4 times and 3 times. Now we're going to have our denominator of 36. And it's going to be 15 minus 32 over 36. Now we may want to use the t-chart to help us. Since the 15 is positive, the 15 will go on the positive side, the 32 is negative, it'll go on the negative side. So remember, it says if they're on different sides, move the smaller and subtract and find the difference. In this case, when we subtract, we're going to borrow from the 3 is going to become a 2, and this is going to be 12 minus 5, which is 7, and 2 minus 1, which is 1. Since we're on the negative side, we know it's negative, so our answer is negative 17 over 36. This is the last example. So in this particular case, it works out the same exact way, giving us now negative 21 minus 20 over 36, which is negative 41 over 36. Or we can write it as negative 41, 36. Or even 41 over negative 36. The last way we're not going to use much until we get into a topic called slope, rate of change. Now we can see all 3 of these are considered in simplest form, but how did I get that negative 41? So in this particular case, since the 21 is negative and there's a minus sign in front of 20, they're both on the same sign. If they're on the same sign, we just add and we get a total of negative 41. But there's still an issue with this one because these are called improper fractions. So we're going to have to write them as a mixed number. So 36 goes into 41 one time. 1 times 36 is 36. When we subtract, we get 5. And we want to put that remainder over our divisor. And we know our answer is negative. The end. Make sure you finish your assignment. And again, this problem right here is very similar to the sneaker problem we did in class. Let's make it happen, and you guys have a great day. Bye-bye.